10. Quantum tunneling anomalies. In the realm of quantum mechanics, particles occasionally defy classical laws. Researchers have observed instances where electrons pass through potential barriers. This phenomenon is technically known as quantum tunneling. It suggests a non-zero probability for matter to exist on the other side of an obstacle. Early physicists like George Gamow provided the mathematical framework for this in 1928. While standard in microscopic scales, macroscopic tunneling remains a theoretical ghost. Some researchers hypothesize that specific environmental triggers might induce this state. These triggers are often associated with high-energy cosmic events. Imagine an object moving through a solid surface without disturbing the atoms. The energy requirements for such an act are currently beyond human engineering. Yet, data logs from clandestine labs suggest such breaches were attempted. These experiments often focus on manipulating wave function collapse. Success would redefine our understanding of physical boundaries. Most experts remain highly skeptical of these undocumented reports. However, the theoretical possibility continues to intrigue modern shadow physics. We are looking at a frontier that challenges the very nature of solidity. 9. The Casimir-Vac-UEM harvest. The Casimir effect describes an attraction between two uncharged plates in a vacuum. It arises from fluctuations in the quantum vacuum energy. Hendrik Casimir proposed this in 1948 as a testable prediction of quantum electrodynamics. Measurements have since confirmed this force exists at the nanometer scale. Theoretical researchers wonder if this energy can be harvested. Extracting work from the vacuum is considered impossible under thermodynamics. However, some papers suggest non-equilibrium vacuum states could change this. Imagine a turbine spinning in a void, powered by nothing but space. Such a machine would defy current energy conservation laws. Investigations into this area are shrouded in academic controversy. Many labs cite the instability of the vacuum as a protective mechanism. Yet, secret research nodes have reportedly sought to stabilize these fluctuations. They aim to create a perpetual power source from the ether. This pursuit often leads to the destruction of the equipment used. The danger lies in the potential for localized vacuum collapse. We are dancing on the edge of a fundamental physical limit. OLT fusion resurgence. Cold fusion remains one of the most polarizing topics in history. In 1989, Pons and Fleischmann announced a reaction at room temperature. The scientific community largely rejected these initial findings due to replication failures. However, new research centers are quietly revisiting the palladium-deuterium interaction. Modern experiments use nanotechnology to influence reaction sites at an atomic level. Some data suggests excess heat generated without significant radiation. This defies our current understanding of nuclear binding energies. The implications of low-energy nuclear reactions are massive. Clean energy, zero emissions, and portable power could change the global landscape. Yet, big energy stakeholders have historically pressured these projects into silence. Many independent researchers now operate in decentralized, small-scale environments. They argue that the earlier errors were due to measurement limitations. Advancements in calorimetry have allowed for more precise tracking of energy outputs. A recent study noted a 20% efficiency increase in closed cells. While mainstream journals remain cautious, the underground progress is undeniable. The search for a stable, high-output cold fusion device continues. It represents the ultimate pursuit of star power on a workbench. Biological telecommunication. Theoretical biology explores the possibility of intercellular communication via specific frequencies. Some suggest that cellular processes can be influenced by electromagnetic oscillations. Researchers propose that DNA acts as a biological antenna for these signals. The controversial claim is that this can reverse cellular degradation. This would, in theory, allow for rapid healing of brain tissue. Experiments conducted in private consortiums have supposedly yielded positive results. Witness testimony describes these sessions as highly focused and secretive. The core technique involves high-frequency resonance matched to biological patterns. Critics point to the lack of peer-reviewed data as a red flag. However, the potential to fix damaged neurons is a holy grail of medicine. If sound alone could repair the brain, our healthcare system would be revolutionized. We are talking about non-invasive regeneration that bypasses chemicals. Of course, the risk of misuse is equally high. Someone could theoretically program biological processes through external signal injection. It is a dual-use technology that scares and inspires. The loss of evidence in these cases only fuels the mystery. Phononic invisibility. Phononic invisibility involves the manipulation of sound waves to hide an object. By creating a metamaterial shield, sound passes around the target as if it were not there. This is different from optical invisibility, which deals with light. The math behind this requires complex negative refraction indices. Researchers at elite technical universities have successfully demonstrated this at small scales. The object is shielded from acoustic detection, rendering it silent to sonar. Some claim this can be scaled up to protect larger structures from vibrations. This has military applications in stealth technology and anti-vibration housing. The challenge is in the frequency range. Blocking all sounds is difficult. Yet, recent advancements in materials science have bridged these gaps. A field that bends sound could also be used to protect delicate structures from earthquakes, or it could be used for advanced clandestine operations. Imagine a device that makes a vehicle silent to all sonic sensors. Such technology exists in labs today, though it is often classified. The intersection of physics and sound engineering is truly a burgeoning field. It proves that what we hear is as controllable as what we see. Gravity wave manipulation. Gravity waves were predicted by Einstein but detected only recently. These ripples in space-time are generated by massive cosmic events. Some theorize that localized gravity waves could be generated artificially. This would allow for the manipulation of space-time itself. If we could bend space, we could potentially create warp-like propulsion. The energy required to perturb space-time is astronomical. However, advanced models suggest that resonance might lower these requirements. Projects investigating this often involve high-spin superconducting materials. Some suggest that gravity and electromagnetism are deeply linked at a fundamental level. By pulsing electromagnetic fields at specific harmonics, space-time might ripple. The military interest in such a propulsion system is immense. Imagine an aircraft that doesn't fly through air, but moves space itself. This would explain many high-performance aerial anomalies. It would also explain the absence of sonic booms and inertia. We are looking at a technology that could bypass the speed of light. Many mainstream scientists dismiss this as impossible, yet rumors persist. The data hidden in the archives suggests we have come closer than thought. Neutrino oscillation modification. Neutrinos are nearly massless particles that flood the universe. They pass through matter without interaction, making them notoriously difficult to track. However, researchers in underground facilities have attempted to modify their timing. By using intense magnetic fields, they aim to change the oscillation state. If the arrival time of a neutrino can be shifted, it creates an apparent faster-than-light speed. This contradicts standard relativity, but aligns with some fringe theoretical models. Some hypothesize that space-time is not uniform at the particle level. An experiment in the late 1980s claimed a consistent anomaly in travel time. These researchers were later suppressed and their data confiscated. The implications were that time causality could be breached at the subatomic level. If you can move information faster than light, you can essentially send data to the past. The physical laboratory was buried in deep shielded environments to avoid external noise. They were looking for the fundamental clock of the universe. When the project was shut down, all equipment and records disappeared. It remains one of the most chilling cases of scientific erasure. Room temperature superconductivity. Superconductors allow electricity to flow without resistance. This creates powerful magnetic fields and zero energy loss. Currently, this requires extreme cooling to near absolute zero. Scientists are hunting for a room temperature superconductor. If found, it would render our energy grid perfectly efficient. It would also enable high-speed magnetic trains and advanced computing. Recent reports claim to have found stable materials at ambient pressure. These studies often emerge from private labs, away from institutional eyes. The results are frequently scrutinized, yet some remain persistent. The challenge is in the molecular structure, creating a tight lattice for electron pairing. If we solve this, the world changes instantly. We could run the entire grid from a single plant. The cost of such a material would be astronomical, making it highly valuable. Corporations are spending billions in secret to acquire this technology. A few leaked prototypes show magnets levitating without cooling systems. These items are tracked and recovered by intelligence agencies. It is a race to claim the future of physics. Quantum entanglement teleportation. Quantum entanglement allows two particles to share state information instantaneously, regardless of distance. Einstein called this spooky action at a distance. Modern research has successfully teleported information between particles across vast distances. Some theorists argue that this can be scaled up to macroscopic objects. If we can map the quantum state of a complex object, it could be reconstructed elsewhere. This would bypass physical travel. The process is computationally intensive and currently limited by decoherence. However, Secret experiments claim to have successfully moved matter. We are talking about state transference that defies spatial constraints. The implications for logistics, security, and human travel are infinite. The risks include data corruption and informational loss during transfer. Many believe the technology exists in classified hands. The sudden disappearance of labs and staff supports this narrative. It is the ultimate boundary of what is possible in our universe. If physical objects can jump across space, the concept of a border is obsolete. We are moving toward a future where distance is merely a variable. 1. The zero-point energy field. The zero-point field is the lowest possible energy state of the quantum vacuum. It is a fundamental pervasive energy that underlies all of reality. Some theorists argue that we live in a sea of energy that is currently untapped. If we could tap into this, we would have access to infinite power. Tesla was famously obsessed with the idea of extracting energy from the ether. Modern researchers suggest that vacuum fluctuations could be the key to interstellar propulsion. The energy density of the zero-point field is effectively infinite. Capturing even a fraction of this would change everything. Yet, experiments in this field are almost always shut down by authorities. The threat is that this energy could be weaponized or disrupt the global market. Despite this, rumors of secret projects working on zero-point generators persist. Some suggest they have already been successful in small-scale tests. These reports are always followed by the total destruction of the research data. We are standing on the brink of an energy revolution if we can survive the discovery. It is the greatest secret in modern physics.